Hello, everyone. We're going to talk about polynomials today. This should be review, but it's going to be. I noticed when I taught this yesterday that quite a few kids had some really decent questions. So I want to make sure those get answered. So if you have questions as I'm teaching this, make sure you jot them down. Maybe send me an email because this lesson was supposed to be pretty easy, but I just want to make sure that you're really understanding the stuff. It's really big on the SAT. And like I said, if you have questions, make sure you ask them. Okay, so first, a little bit of vocab. What is a polynomial? Well, a polynomial is it's a one of some of them. Okay, the ones you already know are called linear polynomials and quadratics. Those are both polynomials. And linears obviously are lines, your mx plus b. And quadratic is obviously your ax squared plus bx plus c. Okay, so what is a polynomial? It's an equation, and it's a number x to some power plus a number x to some power. Continue, continue, continue until you just get a number. Now, there's some rules about the powers. The powers have to be, we're going to say whole numbers, even though I like to think more of natural numbers. And remember, the difference between whole numbers and natural numbers are that whole numbers have the number of the whole in it. So they are also going to say that a constant is a polynomial, so like y equals 3 or y equals a number is a polynomial. I don't like that as much, but it's fine. So that would be x to the 0 because x to the 0 is the same thing as 1. Any number to the 0 power is 1. Kids have a really hard time with that fact, and I'm going to talk about that again in a minute. But so technically the power could just be any whole number because 0 would count. But natural numbers are the ones that have more of the things we're talking about. But this can go up to what we call cubics. That would be the next thing. Quartic, which would be degree 4. Quintic is degree 5, and so on. So what is this idea of a degree that I'm talking about? Well, a degree is the highest exponent. It is the highest exponent that shows up in your polynomial. And it's really important because it gives us a hint to what the graph will look like. So you guys know when I say 2x plus 4, that it's going to be a line. How did you know it? Because there's just an x to some power. Same thing with quadratics. Even though here there's a 3x squared and a regular x, you guys know because there's a square, it's going to be a parabola. So the degree gives you a hint to what that graph is going to look like. Now, the leading coefficient, that is the number in front of the degree term. And the degree term is the piece that actually has that highest exponent, and we're actually going to call that the leading term as well. The leading term and the degree term are similar. And the number in front of the degree term is super important as well because it will tell you like if it's smiling or if it's frowning. So we think that's a really important part of polynomials as well. And then the last thing is the constant, and that is the number at the end. And if you were in class, I would ask you what that would mean, and somebody would come up with it. The number at the end is important to polynomials because it is actually the y-intercept. Because if you plug in 0, all those x's will drop out, and you will just have the constant. Now, Ryan asked a really good question that's worth discussing. He said, so what's not a polynomial? Because almost everything you guys have experience with are polynomials. So what's not polynomials are your absolute values, your square root graphs. If you have a polynomial over a polynomial, it's not a polynomial. That's called a rational graph. So if you had like 2x plus 1 over x squared plus 3, that's not a polynomial. 1 over x or those types of things are not polynomials. We have things called sine and cosine curves that you'll learn about next year. Those are not polynomials either. It really has to follow that form a number x to some power. But most of your experience thus far really is with polynomials. Okay, so we can do things with polynomials. We can add, subtract, multiply, divide. Now, addition is just combining like terms. Do you remember when we talked about the idea of the square root of 2? Remember, we said 1, 1, square root of 2. And I said, you guys were a little confused, like, what does 5 square root of 2 mean? Well, it means that I had 5 things that were this length, the square root of 2 length, because it's like its own length, kind of like inches. So like this would be 3 square root of 2's that I just drew out. So, what you do when you're dealing with x squareds and x's, because x can be assigned a number and x squared can be assigned a number, if I have an x and then I have 3 more x's, those x's can go together and that's a total of 4 x's now. Because we don't know what the number is. It could be 2 or it could be 3, but if I take one of those plus 3 more of those, I will then have 4. And x squareds go together for that same reason. They are like terms. Um, I do want to caution you when we're doing this stuff like addition and subtraction. I heard a couple kids yesterday say add to both sides or subtract to both sides. No, we only can do those when you have equality signs. That's the rules of equality. You can add to both sides or subtract to both sides. When we're going to be adding these polynomials together, we're not going to have a both sides. There's not going to be any equal signs. We're going to like basically be simplifying and get something equal to it. We're going to be filling this out. So you can't add to both sides. Basically, it's more like I say cleaning up a lot of times, like just getting your stuff together, clean up your room a little bit. So combining like terms is what we're going to do. And then there's this idea called standard form, which is important. Basically, we're going to put it in decreasing power if possible. Now, for some strange reason, this text does something. It talks about polynomials in 2 variables. I hate it. We don't graph these, but if you have an xy squared and then like a 3x squared and a 4y squared, like what goes first then? It doesn't matter. Don't worry about this. Only worry about standard form if there's one variable. The 2 variable stuff, I really wish it kind of didn't show up, but it did. Okay, so let's look at these. Are these guys in standard form? Is this in standard form? And the answer is yes. This is a polynomial if I had y equals, because it's just a line. There's no other things to decrease, so it's fine. Now this one is not. This one is not in standard form because you see how the degree here is 2. The highest exponent is 2, but it's in the wrong spot. It's in the middle instead of that leading term. If I wanted to put it in standard form, I would have to rearrange the pieces to look like this. So that is not in standard form. Is this in standard form? Yes. The degree term is 1. This is a linear polynomial, and it is in the right order. And this guy is not. I could turn it into standard form by putting the x term first, and but it's not here. Okay, so go ahead and write this one in standard form. If you want to pause it, you can. Okay, and it should be 3x squared. But did I just do it? This is what I did, so whatever. I get spoiler. Okay, let's move on. So let's add some of these. Now, what I want you to do is realize that I'm taking this cubic polynomial, this degree 3 polynomial, and I'm adding it to a degree 2 polynomial. So do you see how down here they put parentheses? You could use those if you want. It kind of helps you realize what's happening. So this I have a cubic and I'm adding to it a quadratic. Now, they just used words here, but really we're just going to clean it up. Now, because of addition, there's a couple things I want to talk to you about here. All the rules for adding hold true still, like order doesn't matter, it's commutative. You can change the order. But do you see these parentheses here? They help me see what's happening. I'm taking a cubic plus a quadratic. But if I don't have the parentheses here, I don't necessarily know like how maybe this was just this much and then this was the other one. Or maybe all of this was one and then this was the other one. Like what's going on here? So the parentheses actually are funny with addition. They end up being optional because we're just going to be cleaning up and combining like terms, but they're helpful because they can kind of see what's going on. So are the parentheses necessary with addition? Not really. But are they okay? Absolutely. Okay, but we're just going to clean up. I'm just going to add this to this, which means see how many x cubes I have. Well, here's an x cubed. There's no other x cubes to add with it over here, so I just have x cubed. Now, how many x squareds do I have? Well, here are 3x squareds. Here's negative 2x squareds. So if I have 3x squared and I take away the 2x squared, I just have 1x squared left. 4x and 6x gives me a total of 10 x's. And then I have a negative 5 and a positive 8, which gives me positive 3. So when I add this cubic to this quadratic, I do get a cubic first. Quadratic we talked about yesterday too. It's kind of funny. It's the first one you learn and you're so good at it. And then everyone forgets its degree too because of the stupid prefix quad. I don't know why that happens. I keep meaning to ask somebody because you want to say 4, but if it was a degree 4, it would be called a quartic. Okay. So don't forget that quadratic is 2. Okay, why don't you go ahead and pause it and see if you can do this second one. They did put the parentheses, but remember they're kind of optional. It's just telling us what's going on. Addition is just about cleaning up. Okay, so what do I have here? I have a quadratic and a quadratic kind of. This is those two variable things I told you they're kind of stupid. So don't let it trick you up. Doesn't matter about the order, just combine like terms. So I have a 3a squared and a negative 3a squared. So those a squareds are all the way gone. I no longer have any a squareds. I have negative 5ab and 8ab, which leaves me with 3ab's. And then I have 1b squared and I add 2 more b squareds. That gives me a total of 3b squareds. So if I add those together, this is what I get when I simplify. Okay, what if there are nasty decimals? So what? So what? Now, some people suggest this idea of vertically adding them. I think it's kind of stupid. I will show it to you. Don't think it's necessary. It's just a way for you to see the like terms. So I'm adding them up. So I have an 8. So it would just go where there's any other numbers and there's not. So I would put the plus 8 over here. Negative 18t I can stack up with the other 18t for safekeeping, and the 0.6t squared I could put here for, it's just a way to sort your like terms. I do a lot of like squiggle marks for the cubes, and then I'll underline the t squareds. It's kind of a similar game I do. I'll box this one just so I can keep track, but they're going to go this way. So that's a 1.9 t squared. There's no, oh, Mrs. Bruno totally garbaged that up. Thanks, guys, for telling me. Feeling kind of lonely. That was a cube, wasn't it? So now the point t squared would go here. Sorry. Is that right? A negative. Yeah, that's better. Okay, so I have 1.3 t to the third. This will be 1 t squared when you add it, or just t squared. That one is optional. Negative 24 and negative 18 will be negative 42t, and then plus 8. This is in standard form, 3, 2, 1, and number. Okay, subtraction. Kids do have a hard time with subtractions, but you know subtraction is a little bit easier. Complicated than addition. So don't let it mess you up. There's like 3 ways to think about this. You could think about it as distributing a negative. Parentheses are necessary here. You can also think about it as subtracting all the pieces. You must subtract each piece. And some people say subtraction doesn't exist. It's the same thing as adding the inverse, adding that inverse, in which case you would find the additive inverse, which is the same thing as subtracting all the pieces, or distributing the negative, and you could think of it that way. So what is that idea of adding the additive inverse? It's what would cancel with everything to get it 0. So you basically just change all the signs. So instead of a negative 7y squared, it would be a positive 7y squared. Instead of a plus x squared y, it's a negative x squared y. Instead of a minus 3xy, it's a plus 3xy. And instead of a minus 7x squared, it's a plus 7x squared. So that would be the additive inverse, just changing all the signs. So like I said, the parentheses are necessary here because you need to know what polynomial you're actually subtracting, because you're subtracting the whole thing. It's not just a negative piece like the negative 5 there. Okay, so with words, kids struggle. And it's because of the way the idea of subtraction works. Because you subtract something from the original and the order is kind of messed up. If you're looking at something like this that seems confusing and you're confused, like make it a simpler question. If I tell you to subtract 2 from 6, what are you going to do? You're going to take 6 and then you're going to subtract the 2. So you're starting here with this x cubed plus 3x squared plus 4x minus 5. From that, you will subtract this piece, the 6x minus 2x squared plus 8. So that's where that order comes in. And now are your options with how you want to handle it. You can subtract each piece or distribute the negative. I usually prefer to distribute the negative and write below it minus 6x plus 2x squared and minus 8, which is very similar to that idea of the additive inverse, because that's what I basically just wrote down. Okay, and now I will use this x cubed and see if there's any other x cubes, and there is not. There's a 3x squared, but I'm going to add to it 2x squared, which gives me a total of 5x squareds. 4x minus 6x is negative 2x's, and negative 5 minus 8 is negative 13. So that's what you're looking at with subtraction. Why don't you pause and see how you can do on these two guys? And now I'll go ahead and work them. Okay. So I'm going to go ahead here and distribute this piece as well. This one's a 2 variable, so don't worry about the standard form again. That will be a 3a squared, a minus 2b squared, and a minus 8ab after I distribute that negative. And now I'm combining like terms. So I have 3a squared and I have another 3a squared, because look, that was 3a squared minus a negative, which becomes plus a positive. So it is 6a squared minus 5ab minus 8ab. I'm getting a negative 13ab. And now I have b squared minus 2b squared, which is minus 1b squared. The 1 is optional. If you want to put it, please do. Minus b squared. And the last one here, go ahead and distribute this as well. So I have a negative 6x, a plus 2x squared, and a minus 8. So x cubed, no x cubes here, so that's all we have. Ooh, a little bad there. 3x squared plus 2x squared, that's a 5 now for my x squared. 4x minus 6x, that's negative 2x. And negative 5 minus 8. Is this the same one as this one? It's the same one as this one. Negative 5 minus 8 is negative 13. Okay, so they just showed you a way you can write it out, I guess. There we go. Now, let's talk about exponent rules. My thoughts on exponent rules, and great questions were asked in third hour about this because I told them a little secret. All of your math teachers in this school think you should already know this. Usually at the beginning of the Algebra 2 year, I give a review packet and I put the exponent rules on here. And everybody thinks you should know it, and you guys are notoriously bad at it. And do you know what I think happened? I'm not for sure, but I think what happened was it was taught pretty heavily in 8th grade math, and a lot of you went to Algebra 1, so you didn't have 8th grade math. So I think it might just be a gap. I did hear that you are talking about it in chemistry as well, so these things will happen. But the most important thing about exponents is you do know what an exponent is. You know that x cubed is the same thing as x times x times x. So you need to make sure anytime you're dealing with these rules, they all make sense. That you just ask yourself, what does this mean? And you will get it right, I promise. Okay, so the exponent rules we know. If you have x cubed times x squared, we do add them, but nobody memorizes multiply, add. You don't have to. Just say, what does this even mean, brain? Well, x cubed means x times x times x. X squared just means x times x, and they're being multiplied together, so you can push them together. And what did I do? I added. Now, what happens if I have x cubed squared? This is called power to a power. Well, what does that mean? It means I have x cubed times x cubed, because if it's squared, it's x cubed times x cubed. Well, what does that mean? Well, just what I said a second ago, x times x times x times x times x times x. So that's x to the 6. So how can I get there from here? You multiply. That's called power to a power. And the last one is division. If I have x to the 3rd over x squared, what does it mean? It means x times x times x over x times x. Well, x over x is the same thing as 1. And this is the same thing as 1. So that simplifies and leaves me with just x, or x to the 1st. That comes from subtraction. And if it was the opposite way, where x squared was over x to the third, the idea is the same, except that x is left in the denominator spot. And you would have to put a 1 as a placeholder, and x squared over x to the third is 1 over x. And this is where that x to the 0 equals 1 shows up. Because you guys know that x to the third over x to the third, anything over itself is 1. But if I would do that subtraction rule, it would be x to the 0 equals 1. So that's why anything to the 0 power equals 1. Now, unfortunately, where some of you get confused that was discussed yesterday in class is instead of the x, what if you have 2 cubed times 2 squared? The question is that 2 to the 5th? Or they wanted to know, is it 4 to the 5th? And the answer is, guys, your brain knows. 2 times 2 times 2 times 2 times 2. It is 2 to the 5th. You don't multiply the 2 times 2. If you would have changed that to 4 to the 5th, I want you guys to understand how big of a difference that is. That's 4 times 4 times 4 times 4 times 4. Each one of those would be doubled. Each one of them. So if you take 2 to the 5th, you get 32. But if you take 4 to the 5th, that's 1024. I want you to realize how much you messed that up. Okay. The base stays the same. You add the exponents. Now, what if you have 2 squared to the third? Yeah, if you wanted to change it to 4 to the third, you could. That's okay. But it's also the same thing as 2 to the 6th. So 2 to the 6th and 4 to the third are the same thing. Well, how does that make sense? Well, that makes sense because 4 can be written as 2 squared in disguise. So that's where 4 to the third can be the same thing as 2 to the 6th. Okay? So the problem is when there's a number. And if you still have confusion with that, I really want to spend some time talking about it so that you understand. If the number is a base, you don't multiply. Bases don't get multiplied. Only the exponents are what we mess with. So let's go ahead and simplify this. If you need to expand it out, you can. But the -2 will just stay put. Now I have x to the third and x squared. If you need to expand it to see that it's x to the 5th, you can. And this will be y to the 7th. We will be adding those exponents. Now, one thing kids are superstars at are distributing. Some of you have this burning desire to distribute all the time. So this is not something you struggle with. That is 24x plus 32. And this is very important when we're talking about multiplying polynomials because this is a linear and this is a constant, and we just multiplied them. Okay, we just multiplied a bunch of what we call monomials next. See, this is another type of thing we didn't talk about. Monomial, binomial, and trinomial. These are basically just the number of terms. So monomials are something like y equals x, just one piece. Y equals x squared is also a monomial, just one piece. Y equals 3x is a monomial, one piece. What makes a binomial? If there are two terms or two pieces, x plus 1. X squared plus x, that's two pieces. Or x squared plus 3. And then trinomials are your x squared plus 3x plus 4 or something like that. Okay, those are three pieces. So this was a binomial and a monomial, a linear and a constant. Lots of vocab today. You will get better as the year goes on. Now, they made this beautiful little chart for you to help you with multiplying. I think it's kind of stupid. But basically, they're telling you if there's one term means monomial. If you multiply monomials, you just use exponent rules. If you take a monomial times a binomial, you will distribute. If you take a binomial times a binomial, you will double distribute or FOIL. Remember, that's an acronym for first, outer, inner, last. And when you take the big guys times each other, they call it distributive property. Sometimes I call it to double distribute, but it's just the distributive property. So let's practice. And this is the one where kids were confused when I talked about the bases. So when I multiply these two guys together, what do I get? So I will take the 6 times -3. That is negative 118. Excuse me, 1 8 to 18. They wanted to know, well, why can you multiply those? Because the 6 is not an exponent, it's a coefficient. The 2 is an exponent to the a only. It doesn't go with a 6. So you do still multiply numbers because what this really is saying is this. And you guys know that when you multiply, it is also commutative. You can change the order. So all this did is rearrange things. So I'm multiplying the numbers first and now all the a's. You see what's happening? I'm just changing the order. So a squared times a to the 5th, I would add, that's a to the 7th, and this will be b to the 6th. So these are not exponents, which is why it was okay to multiply them. On this one, you will distribute. You will be careful with exponent rules. So this will be 10x to the 5th plus 5x to the 4th minus 15x squared. I have seen some teachers teach with this like area model. Some kids really like it. Do it if you need to, where they just put all the pieces up top and then they can just multiply this way. That'll be 5x to the 4th and negative 15x squared, and then get the answer that way. That's also perfectly fine. What happens on this problem? This one had lots of discussion. If you want to pause it and think about it first, you can. Basically, it's talking about a cereal company. Like I said, my grandma used to buy me those cute little, like variety packs of cereal because she didn't know what we wanted, and I thought it was so special. But obviously, it looked just like a little mini of the big boxes. So what they're saying is a cereal company has different size boxes, but they all look the same from the shelf. They're all similar if you think from geometry. So they want to know if the length is 4 times the width. That's a fact. And I can write that as an equation. Length is equals 4 times the width. The height is 3 inches greater than the length. So that's the length plus 3. Write an expression for volume. And we all know that volume is length times width times height. But we don't want all these different variables. We really just want one variable. So I have the length and the height, but what is the width? Well, the width is just the width. So we'll just use the width the same. The length is 4w. The width is w. Can I write the height in terms of width? And the answer is yes. Because the length is 4 width, I can substitute that right there, and I can get my last one as 4w plus 3 instead of length plus 3. And if I want to throw them all in parentheses, I can, and I can multiply them. So how do we multiply 3 polynomials? Because this is a monomial. This is a monomial, and this is a binomial. We just multiply 2 at a time. And you can choose. I would choose to multiply the easier ones first personally. So it's 4w squared, and now I'll take that times 4w plus 3, and I'll use my exponent rules and distribute 16w to the third plus 12w squared. Okay, why don't you pause it and try this one on the bottom? Okay, I would also, like I said, multiply those first. It's not wrong to not do that. I'll show you what that would look like in a second. Distribute 2a to the 7th minus 16 a to the 6th plus 18 a to the 5th. So what if you made it more difficult for yourself? And what if you multiplied the back two first? It's fine. If I multiplied the back two first, I would have distributed. I still have the a squared. I would have 2a to the 5th minus 16a to the 4th plus 18a third. And now I just have to distribute again. It's just more complicated, and I will get to the same answer. Okay, so order doesn't matter with multiplication. It does with subtraction, though. It does with subtraction. Okay, so let's practice multiplying these binomials. Sometimes there's like terms, sometimes there's not. On this one, there's not. This is called FOIL, first, outer, inner, last. So we will double distribute, and I'll get AD. I could have done the right order, maybe. A times C plus A times D plus B times C plus B times D. Again, if you had a teacher who taught you this way, where you put the A and the B here and the C and the D here and multiply AC, AD, that doesn't look like a C, BC, and BD, and then look for like terms, you'll get the correct answer. There's no like terms on that one though. It is usually best to put them in alphabetical order, but it's not wrong if you don't. Okay, how about this one? Do not mess this up. Number one, missed problem in Algebra 3. I tell kids this, and at the end of the year, they get really good at it. Do not distribute that exponent. That is not what that means, guys. What does it mean? It means 6x to the fourth plus 3 times 6x to the fourth plus 3. And I can guarantee that will be an ACT or SAT question. They love it because kids just want to take that exponent in. It's so wrong. Double distribute 36x to the 8th plus 18x to the 4th. Here's another 18x to the 4th, and that will always happen when you have it. This is called a binomial square. When you have a binomial and you square it, the O and I are always the same. And you get 36x to the 8th plus 36x to the 4th plus 9. So those are the like terms there. And this one here, double distribute, negative 15c to the 4th. Let's put the c's first just because of ABC order. Plus 3c squared d, that's a 4, I'm sorry, it's garbage. Next guy, minus 5c squared d plus 2d squared. There are like terms here in the middle. Mine is really sloppy. Negative 15c to the 4th minus 2c squared d plus 2d squared. Okay, I think we have one more here. Yeah. How far could you do this? You can multiply humongous ones if you want. They suck, but you could do it. These are the ones where sometimes, like I said, the kids sometimes like doing those boxes. I get it. It's very much more organized than Mrs. Bruno's was. Make sure you don't drop any signs. But I like to draw the arrows too. So I'll show you both ways here. This will be 3x to the 3rd plus 6x squared plus 21x. Go with the 4. I do sometimes stack them. 12x squared, let's put it under the other x squared. 8x, I'll put that under the x here, and then plus 28. And then clean it up. 3x to the 3rd plus 18x squared plus 29x plus 28. So if you would have done it this way, you can see 3x squared times 3x is 9x to the 3rd. 3x and 2x is 6x squared. 21x. 12x squared. 4 times 2x is 8x. 4 times 7 is 28. And then you can look for the like terms in the boxes, and you still have to simplify it out. I think some of you called that lattice multiplication before too. Okay, so that's it. It was a lot. You have a homework assignment. You have to get it done. Poly Day 1. Poly Day 1 will be due. Okay, if you have any questions, email me, or we could set up a Google Meet tomorrow, Friday.